All right, hello again, Algebra 2 people. So we're going to spend today just talking about some things with function notation and evaluating functions with function notation. I know a lot of you guys are probably more used to just saying y equals and things like that. But most of the time, like Algebra 2 and above, we see more and more of just function notation and using it for kind of different applications. So what I'd like for you to do is pause the video real quick, and if you can see, I think you can see the screen pretty well. So pause the video real quick and read those first kind of couple paragraphs up to about right here, and then, like I said, pause the video, do that, and then we'll kind of go through on how to evaluate these things. Okay, so hopefully you paused the video and read through that. Just as a quick summary, really what it is. So remember, if you see f of x or g of t or h of n or whatever, the first letter, like f and g, what have, or et cetera, that's just the name of the function, right? The thing inside the parentheses is your input variable, okay? It's always going to be that domain variable, what you're putting into the function. So when we say evaluate, really what we're saying is we are inputting that thing, if it's a number or otherwise, we're inputting that into the function and we're taking the place of that variable, okay? So I'm going to use this first one here, just a kind of an easy example of 5x plus 1. So when we're evaluating, we are plugging in. So we're plugging in for the variable. Okay, so if it says f at 3, in this case, that would just mean 5 parentheses 3 plus 1, and then we can just figure out what that is, right? So that's just going to be 15 plus 1 is 16, and that would be your answer, okay? It is really, it's really a good idea to always use parentheses, even if it's a number. Later on, we're going to see things that aren't numbers, but really important that you do always use parentheses. Think of it on like a bucket, right? Think of your variable as like a bucket, and whatever your input is, you're just sticking that inside the bucket, okay? So f of negative 1, again, plug it in. 5 times negative 1, plug it in for the x, and then plus 1, figure out what that is. Negative 5 plus 1 is negative 4. F of negative 6, again, plugging it in for the variable. Negative 30 plus 1 is negative 29. And then f of 40, 5 times 40, 201. Okay, so when you're evaluating, again, it's literally just plugging in that value. But remember, folks, that f of x, really what it means is we're finding the y value. So really what this is doing when you're evaluating, it's generating a point, especially when you have numbers. So like we just found out what these are. So if f of 3 equals 16, that means we have the point 3 comma 16. F of negative 1 was negative 4, so that is the point negative 1, negative 4. So it's almost like a different way of finding x, y coordinates, and if you're going to graph it or what have you. Okay. So it's the same thing you've been doing back in algebra as far as finding x, y points or something like that. It's just using this new function notation. And again, you did see it in algebra also. But here's the thing, and here's the power of function notation. We don't have to just plug in numbers. We can plug in anything. But the key to remember is what we just said a second ago. Whatever is in there, we are still just plugging, we're replacing whatever that input is for whatever the variable was, right? So remember, my function here was f of x was equal to 5x plus 1. Okay? So whatever that input is, I am putting it in for the x. So this is going to be 5 parentheses, putting in whatever that input is, t, and then the rest of the function. The only way I can clean that up is just kind of get rid of the parentheses, so I can do 5 times t, which is 5t, plus 1. And that's it, folks. That is it. Don't overthink it. Okay? It's unsatisfying because it's not a number. It's an expression still, but it's okay. It's whatever it is. I even like doing goofy things like, what would be F smiley face? Well, we're still putting in the smiley face for the x. So it's going to be 5 smiley face plus 1. And that's, again, if you want to get rid of the parentheses, we can multiply 5 times smiley face. And that's it. Okay? But let's take this one step further. Can we also substitute in like a whole expression? So if I want to put in x plus 1, and again, I know I sound like a broken record, but we're putting that whole thing, we're substituting that whole expression wherever we see an x. So there's our 5. For our x, we're putting that whole thing. It's the same variable. Now we have x plus 1 instead of just x. Plus 1 still on the outside. And now we can clean that up. Don't forget, we can distribute the 5 times the x and 5 times the 1. So it's 5x plus, and remember, that's 5 plus 1, so 5x plus 6 would be your final answer. Doesn't matter what's inside the parentheses, we're just going to plug it in. So 5 parentheses 3m minus 2 plus 1. Again, distribute and clean up. That's 15m. 5 times negative 2 is negative 10. Plus 1 would be that. Okay? These last two are actually called compositions. We won't get to those for real for a little bit though. But when you hear the word composition later on in the year, remember this day, because these are what they are. Okay? Let's look at a couple others. Let's see one more example, and then look at a couple other ways you can look at it from a table or a graph even. So here's another example. So you got g of t equals t squared minus 8t plus 18. And I want you to evaluate those for those values. You got 6 of them. So pause the video, see if you can do those on your own. Do read that top part. If you have more than one variable, whatever that input is, you're putting it in everywhere there's that variable at. So go ahead and pause the video, and then we'll zip through the answers and then get it in the table and the graphs real quick. Okay, so hopefully you got your answers. So remember, anything that input is, we're putting it in for all the variables. So this would be negative 4 squared minus 8 times negative 4 plus 18. Clean it up, just do the math. Don't forget negative 4 squared is going to be 16. Plus 32 plus 18, which looks like is 66. You will learn to love when the input is 0, because that's super easy. So we got 0 squared minus 8 times 0 plus 18. And notice I'm always using parentheses. 0 squared, 0, negative 8 times 0, 0. So this is 18. When your input is 2, 2 squared minus 8 times 2 plus 18. And again, clean it up. 4 minus 16 plus 18 looks to me like it is 6. Plug in 5. And we have, let's see here, that's 25 minus 40 plus 18, which would be, I think that comes out to be 3. That seems right. And then the last two, again, with variables, again, with W, all we do, we just replace it with T. It doesn't matter, number, variable, expression, always replace. So that's just going to be W squared minus 8W plus 18. Again, is it kind of unsatisfying? Yeah, that's what it is. Last one, x minus 4, again, use parentheses. And that's good. So on this one here, I'm going to leave it like that. We can talk about simplifying and kind of combining like terms to get kind of what that is. I'm not worried about that right now for this lesson. But just know, go back to your algebra skills and we can multiply that out and kind of and distribute and combine like terms. But for the purpose of this, the main thing I'm worried about is putting that input in everywhere there's a variable. Okay? All right. Next section here, we can do the same thing with the table. Tables are super easy. Think about this, what would f of 2 be? Remember, this inside here is your input, in this case, your x. So when x is 2, what is f? Well, you find 2 right here, so f of 2 would be negative 3. Think for just a second. If you need to pause the video, what would f of negative 4 be and f of 10 be? Well, f of negative 4, when x is negative 4, f of x is 13. When x is 10, f of 10 is 0. We can even go backwards on this. So now we can solve for x. So we can say if f of x equals negative 1, what is x? Remember, if you have something like this, this is your y value, or your f of x value, right? So if f of x equals negative 1, what is x? Well, it would be 5. We got negative 1 right here, so the x value would be 5. Again, real quick, if f of x equals 8, what is x? That's going to be negative 1. If f of x equals 4, what is x? Notice this one actually has 2 solutions because there's a 4 here and a 4 here. So your x here would be 0 and 7. 2 solutions for those, and that's okay. Last bit with a graph, and again, it works the same way, ladies and gentlemen. So notice here we have f of 3, f of 0, f of 4. These are your x values. So when x is 3, look at that graph. When x is 3, what would the y value be? So we go x is 3 right here, work our way up. The y value is 2, so f of 3 is 2. I'm going to give you just a second to maybe pause the video, see if you can see what is f of 0 or f of 4. So notice when x is 0, that's right here on the y-axis, so f of 0 would be 4, and f of 4, that's over here, that point there is on 0, so f of 4 is 0. How about going backwards, just like we did with the table? Remember, these are all your y values. So when y is 3, what is f of x? Well, this really has 2 solutions too, right? So when y is 3, well, it's right here, so x is equal to 1. But we can also say this right here, and this would just be an estimate, so I'm going to call that, I don't know, like 2.7, something like that. And again, last two, think to yourself real quick, if y is 1, what is f of x? What is x rather? If f of x equals 5, what is x? So for 1, it also has 2 solutions. So we got like this point and this point. So it would be like, what do you think, like 3.5 and 5? And then for f of x equals 5, that only has one solution when x equals 2. So that's just a kind of a little discussion about function notation. I hope that helped out. Tomorrow we're going to see how really being comfortable with the function notation can help with transformations, because that's our next topic we're going to get into tomorrow. Until next time, stay safe.